Okay, so now, okay, as of today's lecture or lesson, okay, we're going to continue back with our electrical fundamentals lecture class again lah. Okay, so for today's lesson, okay, we'll be going to a new topic, a new chapter, that is DC sources of electricity lah. Okay, alright. So this chapter will be discussing about DC, direct current lah, DC sources and the electricity. Okay. Alright, so without further ado, let us proceed for today's lesson lah. Okay. Okay, so the main objectives of this chapter is as follows lah. Okay, let me read out the objectives lah. Okay, so so the objectives here are, the first one is that okay, we'll be able to understand the construction and chemical action of primary cells, secondary cells, lead acid cells, and nickel cadmium cells, and other types of cells lah. Okay, so this is one of the objectives lah. Okay, next objective is we will be able to understand cells connected in series or parallel, and next one is internal resistance and its effect on battery. Okay, next is construction, material, and operation of the thermocouples, and last but not least, we'll be able to understand the operation of photocells. Okay, so in this DC chapter, direct current, DC sources of electricity chapter, okay, so we'll be covering all of these objectives here lah in this topic. Okay, so first things first, what is DC electricity? So by definition, DC, also known as direct current, okay, is the unidirectional flow of electric charge. Okay, so that is the definition of DC. So what is the characteristics of DC electricity? Current flows in only one direction. Unlike AC or alternating current, it constantly changes. Okay, AC is changing. Okay, direct current, the name is already direct, so it only moves one lah. Remember. Okay, so what is the common use of DC electricity? Okay, so the common use of this DC electricity can be found in our daily lives. For example, like in batteries lah, okay, and solar panels and electronic devices lah, like our mobile phones lah. Okay, so as you can see here, based on this image here, okay, for your easy understanding, DC electricity moves in only one direct current lah, in only one direction. Okay, so from negative to positive in only one direction. Okay, next one is construction and chemical action of types of cells. Okay, so under construction and chemical action of types of cells, there is primary cells lah. Okay, so let me explain what is primary cells. Okay, by definition, okay, primary cells is an electric cell that produces current by an irreversible chemical reaction. Okay, so primary cell is produce current in an irreversible chemical reaction. Okay, so primary cells also known as dry cell lah. Okay, dry cell. Okay, the dry cell characteristics of a primary cell is most common type of primary cell battery and functions similarly to an electrolytic cell. So that is the characteristics of primary cells lah. Okay, so what is the structure of primary cells? Cathode, the positive part is the metal electrode or graphite rod immersed in an electrolytic phase. The anode, the negative structure, okay, is a metal container, usually zinc, that encases the cell and acts as an anode. Okay, so based on this diagram here, you can see this is a primary cell, or known as that is found in a common household battery. Okay, so it is a common household battery lah. Okay, this is an example lah of primary cell. Okay, so based on this diagram, you can see the battery. Okay, the primary cell here is positive, known as the insulator. Inside here, okay, here this is known as zinc casing. So zinc casing is anode, means it's negative lah. Okay, and here carbon electrode. Okay, the carbon electrode inside here is known as the cathode. Okay, magnesium dioxide is the material here lah, made up of this material here. Okay, this material here is made up of magnesium dioxide. Okay, so The discharge process of a primary cell is as follows. Electrochemical reaction occurs consuming one of the metals. Okay, so irreversible meaning recharging is dangerous and can cause explosion. That's the reason why it is called the one direction lah. Okay, because it cannot be recharged lah. Okay, so it is irreversible and recharging is very dangerous for a primary cell. So okay, common uses of primary cells are powering flashlights and household items lah. Okay, examples of primary cells is alkaline, silver oxide, and lithium batteries. Okay, so historical note here explains that carbon zinc cells were once popular, but now they are less common. Before, the carbon zinc cells were used lah in the primary cell construction, but nowadays they are less common already. Okay, so next, primary cells. Okay, we're still in primary cells, but alkaline batteries. Okay, so now we're going to jump into alkaline batteries. So in alkaline batteries, the chemical reaction states that zinc reacts with manganese dioxide lah. Okay, this is for alkaline batteries. So what are the features of alkaline batteries? It has higher energy density and longer shelf life compared to zinc carbon batteries. Okay, it maintains the same voltage level over time lah. Okay, so that is the features or advantages of alkaline batteries. So the variation here it states that rechargeable alkaline batteries exist and allow limited recharging. Okay, so this is the variation for alkaline batteries lah. Okay, this is based on this diagram here. Okay, this shows an alkaline battery lah. Okay, alkaline type battery. You can see here lah, it states here on the battery. Okay, next, secondary cell. Okay, so we have covered primary cells. Okay, now we are going to jump into secondary cell. So by definition, secondary cells states that electrolytic cells where the electrochemical reaction is reversible, allowing recharging. Okay, so basically secondary cell allows recharging lah, and primary cells doesn't allow recharging. Okay, so in secondary cell we can conclude that it is reversible. Okay, so it is reversible lah. Okay, example of a secondary cell we can see is a lead acid car battery. So in your car it uses a lead acid battery lah. Okay, so what the electrolyte in a secondary cell is made up of sulfuric acid, known as battery acid, and the positive electrode in the secondary cell is usually made of lead peroxide, and the negative electrode in the secondary cell is made of lead. Okay, so how about the voltage in a secondary cell? Okay, it has 6 cells, each producing 2 volts for a total of 12 volts. Okay, so this is what is inside the secondary cell lah. Okay, so now let me explain the types of secondary cells. So the common secondary cells chemistries are made up of nickel cadmium, reliable but has a memory effect. Okay, nickel metal hydride. Okay, higher capacity than nickel cadmium, less memory effect. Lithium ion, high energy density, common in portable electronics. Lithium ion maybe can be found on the phone battery lah. Okay, lithium ion polymer. Okay, similar to lithium ion but more flexible in shape. So basically, lithium polymer is same like lithium ion, but it is much more portable or much more tiny than lithium ion lah. Okay, next, lead acid cell overview. Okay, now we're going to jump into lead acid cell lah. Okay, it's still in a secondary cell lah. Okay, so lead acid cell. Okay, so the general structure of a lead acid cell is series of cells containing positive, usually lead dioxide, and negative spongy lead plates lah. Okay, so this is the lead acid structure lah. Again, for the electrolyte, it contains a mixture of sulfuric acid and water. Okay, and is constructed with multiple plates for higher current output. Okay, that is the construction for lead acid cells lah. Okay, next, plate separation. Okay, porous separators prevent short circuits and allow electrolyte circulation. Okay, so the sediment settles at the cell bottom. Okay, the casing features here states that um, states that hard rubber casing with terminal posts and vent caps. The vent caps allow gas escape and prevent spills. So this is the casing feature for a lead acid cell lah. Okay. 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 So this shows a lead acid cell construction lah, based on this diagram that you've seen here lah. Okay, you've seen here. So this is the lead acid construction. This is the plates. Okay. This is the cell container lah, covering the lead acid cell. The top here is the vent cap. This is the terminal post. This is the cell power. This is known as the separators, and this is the supporting ribs. Okay, so this is basically the lead acid cell construction. Okay. Okay, now we're going to jump into the battery assembly and connections in a series connection. Okay. 4. Okay, so series connection states that here cell straps connect cells to produce higher voltage. Okay, so the cell straps connect with the cells to produce much higher voltage lah. Okay, so in a 12-volt battery, it is composed of a 2 volt cells lah. Okay, in a 12-volt battery. Okay, so for the battery box here, it states that it is acid resistant metal case for electrical shielding and mechanical protection. Okay, so it is equipped with intake and exhaust vent tubes for safe gas management. Okay, that's the so this is the construction of a battery box lah. Okay, as you can see here, based on this figure, it shows the connection of a storage battery lah. Okay, so they are connected to produce much higher voltage lah together. Okay, and here it shows a battery quick disconnect assembly lah. Okay. Okay, next we're going to discuss about the battery charging and maintenance. Okay, so first, the charging methods usually involves constant voltage method. Okay, initial high current tapers off automatically. Okay, based on that is shown in the figure 5-7 here. Okay, the diagram of the constant voltage charging method lah. Okay, it shows lah. Okay, the method of a constant voltage method lah. Okay. Next, constant current method. Okay, so constant current method means it maintains a steady current, so but there is a risk of overcharging. Okay, so shown in the figure here 5-7b. Okay, the diagram of the constant current charging method. So this is a diagram of a constant charging method. This is a diagram example for constant voltage charging circuit. Okay, next one, battery charging and maintenance safety precautions. Okay, so what are the safety precautions that we must look out for? Okay, hydrogen and oxygen gas release during charging, so there is a chance of explosive risk, so you have to be careful. Okay, so in order to prevent it, so you have to loosen the vent caps and avoid sparks or flames. Okay, so based on this diagram here, okay, it shows a non-spill battery vent plug. Okay, so this is the vent lah. Okay, this shows the lead weight seated, that is not seated. This shows a lead weight seated already lah. Okay, this is in upright position, gas, so that the gas can escape. Okay, this is the vent lah. So basically this is the vent. Okay, so we loosen so that the vent caps, we loosen the vent cap so it can avoid sparks or flames. Okay, next, how about the battery ratings and life cycle of a lead acid cells? Okay, so the voltage rating, okay, states that each lead acid cell has 2 volts. Okay, for a 12-volt battery they contains 6 cells in series. Okay, so in a lead acid cell it is always in series lah. Okay, so how about the amp per hour rating? So the capacity is measured in 1 amp per hour for 1 hour lah. 1 amp for 1 hour. Okay, so for the life cycle of a lead acid battery or a lead acid cell is defined by the complete charge or discharge cycles, usually 500 to 1300 cycles. Over discharging and rapid charging can shorten the battery life, so take note lah. Okay, overcharging and rapid charging can cause the lifespan to be much shorter for a lead acid cell. Okay. Okay, next, lead acid battery testing. Okay, for hydrometer testing. Okay, in hydrometer testing, okay, it measures the specific gravity of electrolyte for charge level. Okay, next, for the specific gravity range, okay, for there is a range lah, so low, medium and high. So let me explain the high one. So high is usually 1.300-1.275, shows that it is fully charged. For medium, it shows that 1.275 to 1.240, it is defined, it is categorized as medium. Okay, for low, it shows that 1.240 to 1.20, so it requires charging lah. Okay, so this is the hydrometer testing lah. Okay, so basically if the hydrometer testing here, it shows low, medium and high. Okay, so for high it is in this range, for medium it is in this range, for low it is in this range. Okay, so next, temperature considerations. So the correction factors needed for readings outside is 21 degrees Celsius to 32 degrees Celsius of range. So when you read using the hydrometer testing, you have to make sure the temperature is in between 21 degrees Celsius to 32 degrees Celsius of range. Okay. Next is secondary cell, but nickel cadmium cells. Okay, so let me explain the overview of nickel cadmium cells. Okay, so nickel cadmium cells are rechargeable batteries used in various applications. They consist of two active materials and a specific electrolyte. Okay, so the chemistry construction of a nickel cadmium cell is states that the active materials are positive plate, known as the anode, that is made up of nickel hydrate, and the negative plate, known as the cathode, is made up of sponge cadmium. Okay, so for the electrolyte used in the nickel cadmium cell is potassium hydroxide solution, usually contains 20 to 34% concentration by weight. Okay, next, the construction of a nickel cadmium cells. It is sintered nickel matrices form a porous plate grid. Okay, active materials are impregnated into these matrices. Okay, so as you can see here, this diagram here, this is an example of a nickel cadmium cell. Okay, this one you go through on your own lah. Okay. Okay, so for a nickel cadmium cells, okay, so the types of plates is stated that it has a thin sintered plates. Okay, so for thin sintered plates is usually ideal for high rate charge or discharge. Okay, and the types of plate is also made up of pocket plates. So pocket plates is an active material that is pressed into pockets for perforated steel plates. Okay. Next, how about the cell voltage for a nickel cadmium cell? So the cell voltage usually is in a typical open circuit, contains cell voltage up to 1.25 volts. Okay. So now I'm going to explain the operation of nickel cadmium cells lah. Okay, so the charging process shows that a charging current is then applied, and then a negative plate loses oxygen, then the metallic cadmium forms. Okay, so next, positive plates become more oxidized. Next, and then gas emissions occurs towards the end of charging and during overcharging due to water decomposition. Okay. So how about the discharging process for a nickel cadmium cell? So the positive plates release oxygen, okay, that is then absorbed by the negative plates. Chemical energy then converts to electrical energy, and water should only be added when the battery is fully charged. Okay, so remember all of this lah for nickel cadmium cell lah. Okay, so based on this diagram shows the charge and the discharge cycle of a nickel cadmium battery. Okay, so this is the discharging process lah, as you can see. Okay, the discharging process, the ions will go back to the positive ion will go to the positive ion will go to the negative. Okay, so when it's charging, negative will go to the positive and positive will go to the negative. Okay, so this is an example of a nickel cadmium cell lah. Okay, how about the replacement guidelines for a nickel cadmium cell? Okay, so the replacement guide states that interchanging batteries. When you interchange a battery, always remember to clean and dry battery compartment when replacing lead acid batteries. Neutralize old acid with ammonia or boric acid solution. And for the preparation, some jar pad should be saturated with a 3% boric acid and solution. Okay, remember. Okay. Next, for the maintenance and safety, okay, for general maintenance, there are three here lah, okay, that should be followed. First is to hydrate cells to replace water loss during overcharging. B, maintain proper torque values for inter-cell connectors. C, keep surfaces clean and dry to prevent grounding parts. Next is the safety precautions, okay. So, wear safety goggles, gloves, and an apron. Neutralize spills with vinegar or dilute boric acid, okay. Remember this. So for how the hazard awareness is, always monitor room ventilation to prevent hydrogen buildup. Okay, remember this. Explosions can occur if hydrogen concentration exceeds 4% in the air. Remember lah. Okay. Okay. Next is secondary. We're still in secondary cell, but is sealed lead acid batteries lah. Okay. So sealed lead acid batteries are increasingly preferred over nickel cadmium batteries in various applications. Okay. So let me read the key advantages a sealed lead acid battery has over nickel cadmium battery. Okay, so sealed lead acid batteries perform better in extended standby applications. For example, emergency packs for inertial reference units. Okay, for nickel cadmium batteries, it performs well in low voltage and full discharge and high cycle applications. So nickel cadmium batteries require matching up to 20 cells to prevent imbalance and cell reversal. So both of these cells have their own advantages and disadvantages. Okay. Okay. So we're still in sealed lead acid battery. So voltage depression, or known as memory effect. Okay. So in nickel cadmium batteries suffer from voltage depression, often referred to as memory effect. For sealed lead acid batteries, do not have this issue, limiting the need for scheduled deep cycle maintenance. So sealed lead acid battery do not have voltage depression or memory effect when compared to nickel cadmium battery. Okay, so voltage depression definition here states that a temporary decrease in voltage in a battery or circuit, often occurring under heavy load. It is caused by factors such as internal resistance, battery chemistry, temperature changes, and capacity limitations. This drop can affect performance and lifespans in devices requiring stable power. Okay. Next. Okay. So we're still in sealed lead acid batteries lah. Okay. So how about the maintenance and testing? Okay. So the maintenance requirement states that nickel cadmium emergency battery packs require complex test equipment. For sealed lead acid batteries are simpler and do not require specialized maintenance tool. Some sealed lead acid batteries include built-in test features for easier monitoring. Okay. How about the failure detection? For sealed lead acid batteries can alert technicians if they are failing. Okay, so it's much better lah. Sealed lead acid is much better. Sealed lead acid battery is much better than nickel cadmium battery lah. Okay. Testing of failure detection circuits can be done using the byte button. Okay. This is lah. Okay, built-in test. Okay. Next, lithium ion batteries. Okay, lithium ion batteries is also considered as secondary cell lah. Okay. Okay, so this shows a lithium ion battery lah. This example here. Okay, so the overview states that lithium ion batteries are rechargeable batteries. Lithium ions move from negative electrode to the positive electrode during discharge and back during charging. So the key components of a lithium ion batteries is the electrolyte enables ionic movement. The two electrodes is known as negative and positive also lah. Okay, same thing, anode and cathode lah. Okay. Okay. So the safety hazards. So let me explain the safety hazards for a lithium ion battery. The safety considerations that we must take into account is that lithium ion batteries can be hazardous due to pressurized flammable electrolyte. So the risk of explosion of fire if charged too quickly. So these lithium ion batteries cannot be charged too quickly. Okay. Okay. So for the testing standards for lithium ion battery, it is much stricter testing standards compared to acid electrolyte batteries. So it requires a wider range of test conditions and additional specific tests. So lithium ion batteries is much more particular lah. Okay, compared to the rest of the secondary cell battery. Okay. So now let me explain the cells connected in series or parallel. Okay. Electrical or electronic components can be connected in various ways, primarily in series or parallel. In a series connection, components are connected along in a single path. The same current flows through all the circuits. Okay. For a parallel connection, components are connected across the multiple paths. Okay. So the same voltage is applied to to each circuit lah. Okay. 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 Sorry. So let me explain the series circuit and parallel circuit lah. Okay. So for a series circuit, the current is same throughout each component. Total voltage is the sum across all components. Okay. Example, 4 light bulbs connected in a series with a 6 voltage battery. Current is constant, voltage drop is shared among bulbs. If one bulb fails, the entire circuit is broken. So that is the disadvantages of a series circuit. Okay, so how about parallel? So the voltage in a parallel circuit is same across each component. Okay, the current shows that the total current is the sum of current through each component. Example, 4 light bulbs connected in parallel to a 6-volt battery. Each bulb receives full voltage and glows. If one bulb fails, other continue to function. So that is the advantage of a parallel compared to series circuit. So if in a series circuit, one bulb blows, everything does not light up anymore. For parallel, if one bulb blows, everything still works. Okay. And based on this diagram, this shows a series circuit. Okay. A series circuit arrangement. This is a parallel circuit arrangement. Okay. Okay. So let me explain to you the comparison of series and parallel circuit. So the current in a series circuit compared to parallel circuit in a series circuit is same to all component. For parallel circuit is the sum of currents to each. The voltage in a series circuit is the sum of voltage across components. For the voltage in a parallel circuit is the same voltage across all components. The impact of failure in a series circuit is that one failure breaks the entire circuit. Okay. For the impact failure of parallel circuit is others continue to function. So like what I explained just now earlier in the previous slide, let's say for example a bulb in a series circuit, okay, when one of it blows, all of it stops. It doesn't work. For a parallel circuit, for the bulb that is arranged in a parallel arrangement or in a parallel circuit, when one of it blows, okay, all still functions. Okay. Okay, so next. So let me explain to you the series connection. Okay. So for series connection is used in battery packs for higher voltage. For example, 12 volts for starting engines. Okay. The typical lead acid battery has 2 volts per cell. 6 or 12 cells in series for 12 volts or 24 volt system. Okay. For the parallel connection, okay, it increases ampere per hour capacity. It is useful for applications requiring longer battery life without increasing voltage. Okay. Okay. So okay. So now just now we have learned about the types of circuits, about series and parallel circuits. Now we are going to jump into internal resistance. Okay. Internal resistance and its effect on the battery. So let me introduce you what is internal resistance. So internal resistance in batteries increases over time due to the conversion of active material to lead sulfate as loads are applied. Okay. So the key point here states that higher lead sulfate buildup results in increased resistance. Okay. Okay. Next, calculating internal resistance. A battery with low internal resistance can deliver high current on demand. Okay. So this is the formula to calculate internal resistance. Okay. So internal resistance equals to no load voltage minus load voltage divided by load current. Okay. So that is how you calculate internal resistance. Okay. Okay. So next, what is the effect of internal resistance? As internal resistance increases, current delivery. How in terms of current delivery, it decreases as the battery heats up. Okay, as the internal resistance increase, the voltage drops under load condition. Okay, temperature impact. Okay, heat lowers internal resistance. Okay, sorry. Something happened just now earlier, so let us continue back lah. Okay, so what is the effect on internal resistance? Okay, like I explained just now, as the internal resistance increase, okay, current delivery decreases as the battery heats up. and the voltage drops under load condition. Okay. For the temperature effect, heat lowers internal resistance and cold conditions increase internal resistance. Okay. So what are the effects of internal resistance? Okay, lead acid batteries have low internal resistance and can handle high current bursts for short durations. However, they struggle with sustained high current discharge, and over time the battery becomes tired and needs to rest to recover. Okay, so that is the effects of internal resistance lah. Okay. Okay. So now I'm going to explain the comparison with other battery technologies. Okay. So in terms of responsiveness, nickel and lithium based technologies are generally more responsive than lead acid batteries. Performance is affected by internal resistance, chemistry, and temperature. Okay. 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 Next. Now we're going to we have learned about internal resistance. Okay. Now let's jump into the introduction to thermocouples. Okay. Thermocouples are thermal devices used for generating electricity. The significant application in aviation includes fire detection system, high temperature engine indicating system. Okay, so the basic principle of thermocouples. Okay, how thermocouples work. Okay, a thermocouple consists of two different metals connected at two junctions. One is hot and the next other one is cold junction. Okay, for hot junction, it is placed in the area where temperature is monitored. For cold junction, it is located in an instrument or data computer area. Okay? When temperature rises at the hot junction, an electromotive force is produced. So the key point here is the produced voltage is directly proportional to temperature lah. Okay? Applications of thermocouples. Okay, one of the common use of thermocouples that can be found is used for measuring high temperature in cylinder head temperature. Okay, in reciprocating engines, and used in exhaust gas temperature in turbine engines. This one is used in aviation lah. Okay, so what are the materials used in thermocouples? Okay, so thermocouple materials. Okay, the materials vary based on temperature range and exposure. Okay, CHT measurement. Okay, CHT is cylinder head temperature. Okay, iron and constantan or copper and constantan. So engine exhaust gas temperature. Exhaust gas temperature measurement is to chromal and alumel. Okay, the unique voltages produced by metal combinations are measured in millivolts. Okay, so what are the limitations of a thermocouple materials? The accuracy can be challenging. Achieving less than 1 degree Celsius system error is difficult. Okay, so thermocouples in fire detection. Okay, so the fire detection system using thermocouples usually in normal conditions. The temperature difference between the two junctions is negligible. Okay, when a fire overheat condition occurs, electricity is produced and amplified to trigger an alarm. Okay. Okay, so we have learned about thermocouples already just now. So now we are going to jump into the photocells. Okay, so what is photocells? Okay, so photocells are devices that convert light into electricity. It is commonly used in electronics and control of mechanical systems. So, okay, how light affects semiconductors? Okay, light is made of electromagnetic energy carried by photons. Okay, the energy of each photon depends on its frequency. All semiconductors are influenced by light energy lah. Okay. Okay, so the mechanism of operation for a photocells. Okay, when a photon strikes a semiconductor atom, it raises the energy level of the atom. This extra energy frees an electron, allowing it to flow as current. The flow of current can trigger various reactions, such as energizing a coil to a closed circuit. Okay, so this is shows a typical photocell lah here. Okay. Okay, so any questions? If you have any questions, feel free to ask me lah. Okay, so basically we have reached the end of this chapter lah. Okay, end of this chapter, long chapter for DC source of electricity. So I think we'll end the lesson here lah for today. Okay, so like I say, if you have any questions, feel free to ask me. Okay, so let's end the class here today. Thank you for your time, everyone. I'll see you in the next lesson. Thank you.